Okay, now I try to run the quiz number 2 to see what's going on. Okay?
But which report is this one?
I said Quiz02 on the in the handout. Right now, you can just write it down and you can download that form, fill it up, and upload it. In the past, I get the one assistant work for me. And now they move him somewhere. So that's what I try to say. I can make it working in the Zoom. Okay, that will be the end. Okay. We go to electronic, okay? Last time we already talking about the diode, but I want to make sure you understand the ideal diode. That means VD equals 0. That will be a anode, that will be a cathode here. And the voltage across the diode, that's telling you VD. That means VD. And you see VD equal VA minus VC. For the ideal VD 0.
Professor, you're
Yeah.
getting a lot of feedback and echoing on your side.
The feedback.
Yeah, and really bad echo as well.
Do you have both your computer and your iPad on, the speaker on?
Yeah, that's normal. Okay, let me see. That's okay. Cannot be feedback. Just a minute. So can you hear now or you get a feedback?
No, but still a little bit of an echo.
I hear you fine. It just sounds like you're really crisp. So no feedback for me.
That's supposed to be that way.
All right, now you're better.
Okay. So when they say ideal diode, that means VD 0. However, we not deal with that. We deal with practical diode. And the practical diode, that will be A, that will be C. And also that will be VD. So VD, same thing. VA minus VC. That's what we call forward bias. That means they allow current flowing from A to C. Okay? That one is reverse bias. That means they open. Current cannot flow from A to C. Okay? And very important thing, when you're working with a diode, you must know is it the forward bias? That means you're talking about diode on. Reverse bias, that means diode off. So when they on, they allow current flow A to C. When they off, they open. Okay? And when you set on, you substitute the diode by the battery. Okay? And that battery will be 0.7 volt for silicon diode. On the magnesium will be 0.3.
So,
Yeah,
question, you said, one thing is 0.3 and the other is 0.7. Can you repeat what 0.3 is?
normally silicon diode VD okay, and if they make by magnesium, and VD 0.3 volt. However, we deal with a silicon diode, so every time you say on, you using 0.7. Okay, not the manual. Okay, when you're working with a Zener diode or normal diode, you must know the diode will be on or the diode will be off for normally. If you're looking on this circuitry, how do we know this diode on or off? Okay, in order to know the diode on, and you have to know the voltage on the anode here and the cathode here. Anode have to be greater than equal 0.7 volt, then they on. Otherwise, they will be off. How do we know? First thing, if you suppose you don't have a diode here, what we out? If no diode here, what we out?
Volt.
Okay, if you don't have a diode here, that means we open circuit. Then V out will be equal 10 volt. And 10 volt higher than 0.7. That's why you have to say a diode on. Okay? And when you say the diode on, again, you must substitute diode by the battery. Okay? So now you can see the diode will be look like plus here, minus here, 0.7 volt. The question is, what is V out? V out, that means you measure from here to the route. What the V out supposed to be? Who knows?
9.3.
Okay, now, if I given you the meter, I want you to measure your car battery. What you think you get?
About 12 volts.
12 volts. So that only telling you one thing. When you measure the voltage across the battery, you get that battery voltage. And this is a 0.7 volt just a battery. So V out you will be measured from here. Okay? From right here to the route. That will be telling you to measure across the battery 0.7. So that's why you get 0.7 volt. And the next question will be, what is the current flow through the R? That will be I.
That will be 9.3.
Yeah. I will be equal the difference between 10 volt and 0.7 divide 1K. Okay? That means 9.3 divide 1K, 9.3 milliamp. What's the voltage across R? That means the voltage across here. Ohm law, I times R. I
10 volt.
9.3 times 1K. You get 9.3 volt, right?
Yeah.
Okay, how did you get V across R again? Can you point to it on the, maybe help us,
Across R, right?
okay.
That's the voltage across. Okay? One side 10 volt, the other side 0.7. The difference will be 9.3 volts. Divide to 1K, you get 9.3 volt.
So in the instance of number 4 on the calculation block there, V would be volts across the resistor, correct?
Right.
Okay.
You can go easy. You get a current I 9.3 milliamp. Resistor 1K. Then you can calculate VR I times R. I will be 9.3. One K. That's what you get 9.3 volt. Either way. The second problem. Diode on or off?
Off.
Off.
Perfect. Diode off. What we out?
10. I mean, sorry, 5.
5 volt. Perfect. What is the current I?
0.
0 amp. Perfect. V across R.
0.
Yeah, you good now. Okay,
Now, let me just for clarification, is it off because of the way the diode is pointing?
now, okay, diode here. A, C, VD, VA, minus VC.
Oh my goodness.
VA, that means here, right? V out. Sorry, VA 0. The thing is they connect to the route. And V out, that means VC. That will be equal 5 volt. Okay, so VA minus VC. That will be VA 0.
Okay, got it.
Okay, 0 minus 5.
Oh, we can't see the bottom part of your screen. Hang on a second. There we go.
Okay, that means you get negative 5. So that's why diode will be off.
Can you go back to the previous screen for a minute? Okay, thank you.
Hey, you're welcome. Okay. Example number 3. Diode on or off.
So,
Yeah,
Off.
yeah, I thought it was off because it's higher after the diode.
Okay, now I said, now you can see, they off. The reason is you get a 5 volt here. 5 on this side, 8 volt the other side. So that means the voltage on the anode less than 0.7. So diode will be off. That's easy to recognize that. What is the current? When they off, what happened? They will be open.
Yep. So 0.
Perfect. You see, now diode will be look like open. So that's why the current flow is here. I equal 0. Okay. Number 4.
Professor, wait, on number 3, I just want to clarify this. It doesn't matter which way the diode would have been position of the circuit, you have a positive to positive, so there is no electrical flow. You have to have positive to negative, right?
Yeah. That means current supposed to flowing from positive 8 volt to the positive 5 volt. If you put the diode the other way, okay? But this is easy to recognize. The thing is, this side will be less than the other side. So the diode off. When they off, they will be open, look like. Okay? And the current. When the circuitry open, current, no matter what, they have to be 0 amp.
Okay.
Okay, last one. Diode on or off.
Ah. Where's the voltage?
On this side, minus 100 volt. Correct?
Oh, I'm
Right.
sorry, there it is. I didn't
This
even,
side, 0 volt.
I'm so used to seeing a resistor there.
Okay, so VD right here. VD equal 0 minus 100. VD will be equal, let's see,
100,
100.
yeah.
So diode on or off?
Oh, it's on. What?
For what? Fire mean on. Anytime voltage at anode higher than voltage at cathode 0.7 volt, then the diode will be on.
Question, Mr. Pham.
What?
A quick question.
Yeah,
So whenever we're doing these problems, it's always a good idea to take the diode out of the circuit and then determine the on and off. Is that correct?
okay. You mean you take out the diode?
Yeah, you want us to take the diode out when we're determining on or off.
Okay, that normally that way. However, this easy way. The thing is they already given to you on this side. Minus 100 volt. Correct?
Yes.
On the other side, ground, 0 volt. Then you have to do a calculation. VD equal difference between anode and the cathode. 0 minus to 0 minus to minus 100. You get 100 volt. 100 volt higher than 0.7.
Can I also say that 0 volts on the 0 on the number line is greater than minus 100. So since 0 is on the anode, we know that it's more positive than the cathode. Is that correct?
Right.
Okay. So
All right, then.
that's another way of saying that the diode is forward bias.
Right.
Okay, thank you.
However, make sure they more than 0.7 volt.
Yes, sir. Yes, sir.
Okay, now this thing here. Zener diode. That's a symbol. That's the anode and that could be a cathode. Okay. A Zener diode. Okay. Either they can be breakdown. What that mean? Breakdown, that mean they get the voltage go with that Zener. I given you example. You buy the Zener diode 10 volt. Okay? And when they break down, then they substitute by the battery, how they look like. And the value will be 10 volt.
So you're saying a Zener diode is always 10 volts or,
No.
okay,
Depend. They can
Right.
be 5 volts. Okay? They can be 15 volt, any voltage. However, when they given you the Zener, they both telling you what the Zener voltage. Like you go to buy the Zener diode,
mm-hmm,
they will be ask you what voltage you want. You can say 10 or 5 or 15, any voltage. Okay?
okay,
When they break down. Now, if they not break down, they working like normal diode. That means substitute the diode by the battery, positive, negative, 0.7 volt. That's a key point you have to know. Okay, now, for this circuit, and the Zener voltage is 10 volt. Okay? So, when you start working with the Zener diode, first thing you can see is it the Zener breakdown or Zener just working like normal diode. Okay? Before you want to know, you're supposed to say, check it out. No more diode. Question A, what voltage here?
10 volt?
20 volts.
20
Oh,
volt.
oh, I'm sorry.
20
Yeah,
volt.
You
Because you
took
still
it
have
out.
you still have a connection on the other side.
Yeah, you took it out. You, okay,
Okay? The first thing you have to do, you have to suppose no diode, Zener, what the voltage at this side, and you know voltage will be 20. Okay, now, if the voltage 20 volt higher than the Zener, then Zener breakdown. Okay? So, Zener breakdown. What happened?
It allows the current to flow through it.
Now,
The highest voltage that'll be on the output will be 10 volts.
they're telling you they break down. That's why you get 10 volt. So that's why you can see in the computer they're using 5 volt. Any higher than 5 volt can cause the damage to the motherboard. So that's why the 5 volt coming in, they will be get the Zener right here. The value will be 5 volt. If you apply 10 volt going to here, then this breakdown, no matter what, you will be get 5 volt. That prevent a damage for the circuitry. So Zener very, very important in the power supply. Okay?
Mr. Pham, where did you get the 5 volts from?
Now the 5 volt, that means you connect into the power supply for your computer, inside your computer. Power
Oh.
supply.
Oh, you're talking about a computer.
Yeah.
I think the question was, they're all rated. Zener diodes have a voltage rating where they operate. That's how you know what voltage it's going to be used for. Is that correct, Professor?
Exactly.
So the Zenode, if I'm understanding what you are saying, is it's there to protect the circuit.
Perfect.
But just from voltage, it doesn't prevent current flow. It will allow as much current as it wants to, correct?
No, no, no. The problem, like the problem in this problem right here. Okay? What they want V out only 10 volt or less, cannot be higher. So that's why they connect the Zener into here with the value 10. Any voltage here higher than 10 volt, Zener break down, then you get 10 volt.
Right. No, but I was saying, like in your second example over here with the 5 and 10 volts. So if you increased it to 10 volts, you're increasing the current through the circuit, correct?
Yeah, that the current can go into inside the circuit.
Right. So even though
However,
this,
if you get 10 volt here, they cut it out, only 5. Okay? That's the purpose for the Zener. They try to protect the circuitry at a certain voltage they want. For this voltage, they want only 10 volt or less, okay? Or less voltage here,
okay.
cannot be higher. So,
Okay.
yeah, go ahead. Okay. Number A, what V out if V in 20? The answer will be Zener breakdown. So V out,
It's 10 volts.
perfect. What is the current through 220 ohm? Easy, right?
20.
Current flow here. They
Oh.
asking current.
Oh, current, sorry.
I will be the different voltage 20 and 10. Divide 220.
So 45.5
Yeah, whatever
milliamps.
you get.
Yeah.
Okay. So that makes it clear for you guys, right? Now, they change the voltage be in 5 volt. The question is, what V out?
Should be, well, if the diode is 10, so
Yeah.
it should be 5, right? Because you haven't gotten through the breakdown voltage,
Well,
correct?
it can be 10 or less, so wouldn't it still be 10?
It's supposed to be 10 or more volts will allow the Zener diode to hit the breakdown voltage, right?
Well,
If it's less than 10 volts, then it won't engage the Zener diode, won't get
Ah.
triggered.
Hey,
Now,
Mr. Pham,
yeah,
you said on these problems, take the diode out, correct?
perfect.
So when you take the diode out, then you have like an open circuit. So then those current flows through the 220 ohms. So then that red dot is 5 volts.
Well, no, it's not an open circuit because the diode is actually branching off. You still have a direct connection to V out. Am I wrong in that, Professor?
Okay, what I'm saying is, when you're working with the diode, you have to know the voltage on this side and on this side. Okay? In order to know the voltage, we already talked to you. Suppose no diode here.
Take
What
the
the out?
diode out.
0.7, 0.7.
Now, what I'm saying is, first thing, you have to know what we here by if no diode here, what we are here.
oop, it
5
would,
volts.
yeah, 5 volts.
Okay, now you get 5 volts. Okay, and you know the diode cannot break down, right?
Right.
The thing
5
is,
volts is less than 10.
the breakdown is 10 volts. 5 volts is less than 10.
Right.
Okay, they not break down. They working like normal,
Like a regular diode.
regular diode, correct? This side is round 0 volt. This side 5 volt. Diode will be
0.7.
if they on the 0.7. However, again,
It's
when
on.
working with the diode, if you don't know they on or they off, you cannot do it. My question is, you get 0 right here. You get 5 volt on the other side. Diode on or off?
Isn't it, it's off.
Off.
It's off.
Diode off. Okay,
0 volts is less than 5 volts.
exactly. Anode here. Cathode here. Diode off, they will be out,
Open.
open. So V out equals 5 volt. Okay, now, last part here. Now they say voltage here will be equal minus 5 volt. What the voltage here? Again, the input voltage minus 5.
Once again, you take the diode out to solve the problem. So when
Exactly.
you take the,
First thing again, you try to find out a diode on or off. Okay. Now, again, no diode, what voltage here?
minus 5.
volts.
Minus
5 volts.
And you know, there will be R naught here. Okay. and the other side will be cathode. Okay. So VD, VA minus VC. What VA?
0,
5 volts.
VA
Oh, I'm sorry.
0,
minus, okay,
-5.
okay. So basically, -5. Okay, so basically VD, let's see, VA 0 and VC -5. So VD equal 0 -5. That will be higher than 0.7 volt. So the diode now will be on. Okay. This, you substitute the diode by the battery. And the other side. Minus 0.7. So V out will be equal -0.7 minus 0.7 volt. Okay, can you do that for me? First thing, they said, if you have a no load, that means first thing they want to calculate without the load. What IL? IL, that means the load current. IG means diode current.
0,
Think what IL equal.
0.
0,
Perfect. Now you get better. IL equal.
Because there's no load.
Yeah, open. Now, next, they will be what the current IG. Okay, so
IZ, wouldn't that be the voltage 24 volts and then minus the VZ voltage
minus the 12,
yeah,
over the resistor?
okay, you're correct. However, I want a little more detail. You can say, if you don't have a Zener and the voltage here will be 24, correct?
Right.
yes,
24 higher than the breakdown 12 volt. So Zener breakdown. When they break it down, you get 12 volt here. And now you want the IG I total the same. You take 24 minus 12 divide 470. Okay? That's how we get. And also they want V out, and you already know. 12 volt. Okay?
Hey, Mr. Pham,
Yeah.
when we figure out IZ, with the load off, IZ and I total, are they the same thing?
The thing I total here, one go here 0. Right?
Well, you said that there's no load, right?
Right. So that means I here go this way.
Right. So that means the current goes to both the resistor and the Zener, which means in this case, I total and the IZ would be the same
Exactly.
without the load.
Right.
Okay, thank you.
And now they want V out with the load. V out with the load equal
12 volts,
perfect 12 volt. I am. Now they want current I am.
So 12 volts over the resistor,
Perfect.
490.
Right. Okay. And IG. IG, you can looking into that. I total minus I am. Okay. I total we already calculated here. That means without the load, total current will be go to the diode. Now get the load. That total current will be going both IG and also IF. Okay, so basically that will be quickly go, okay? Now, you can get the Zener diode VG equal 3 volt. And they apply sideways, okay? Positive and a negative. So when the input positive, okay, 5 volt, and you know 5 volt greater than breakdown, so Zener breakdown. That's why we have 5 volt here, 3 volt here. when you get a negative, okay, what happened to the Zener?
It's not a breakout or breakdown.
They not break down.
No.
The
And
thing
it's
is-
0.07.
Right. The negative, okay, that means you can get -5 here. This is a round. Zener cannot break down. And Zener now will be turned on, right? The thing is you get a 0 volt here and a -5 on the other side. So Zener will be on. And they substitute by the battery. Negative, positive, 0.7. So that's why you can see the output now, they will be negative 0.7 volt. Okay. And another one, they change the Zener diode different way. Answer will be the same. Okay. And in here, they get to Zener. Okay. And basically, when you get positive, okay, then VG1, okay, that means the VG1 for that D1, okay, and also positive and let's see, draw output waveform for a bulb circuit, okay. In that one, they don't give it to you the value breakdown, okay. So VG1.
Mr. Pham, do they want it to be 5 volts because of the sine wave up there is plus or -5?
Oh, yeah, they give you 5 volt here. Okay. So when you apply the positive, okay, then you get the positive here, 5 volt. Okay. So basic 5 volt and if VG equal 3 volt. For example, okay, so D2 breakdown. Okay, D2 breakdown. Okay, that means you can get 3 volt here. And D1 on normal. Okay, on normal means 0.7. So that's why they said VG1 plus 0.7. if I say VG 3 volt, then here you get 3.7. Okay? When you get a negative, that means you get a minus 5 here. Okay? Minus 5 here. So basically, let's see, they given to you minus 3. Minus 0.7. Let's see. D2 breakdown. Now D1 breakdown. Okay? On the negative here. D1 breakdown. And D2 on normal. That given you a little harder, okay,
Mhm.
to figure out. But try to find out for positive, if you can understand that, in order to understand for negative. When the positive, and this one you know, not 5 volt. Okay? And basically, this side 5 volt. What this side?
It coming from ground, so it would be 0, right?
Yeah, if they drop to ground, that means no matter what, they will be 0. Okay? So 0 here. Okay? And now you get 5 volt here. 5 volt greater than breakdown. I suppose to be. VG equal 3 volt. Okay? So you get a 5 volt here. And this guy just on, D1 just on. Okay? That's what we say right here. How come D1 on?
Hey, Mr. Pham, can you use your pointer? We can't see what you're talking about. Can you use your pointer?
Okay, you get 5 volt here. Okay? You see that?
Yes.
Okay. 5 volt here. And this one will be grounded. Okay? So these two here, that means the voltage 5 volt here higher than 3 volt. I suppose VG equal 3. Then this guy break down. Okay? When they break down, they will be 3 volt here. Okay? When you get a 3 volt here, 5 volt here, D1 will be on. On, so that's why you get 0.7 volt for this Zener. That's why I said right here. Okay? D2 break down. So that's why you get a VG. D1 will be on normal. They will be 0.7. So that's why you get 3.7 volt. Okay? However, when they draw it, Okay, for positive here, and that for negative, they just opposite for this circuit. Okay, sometimes it's a very hard to have to analyze it. However, you understand, you know how to using the simulation P-SPI. I can guarantee you that this circuit tree you run, you can get the output will be look like.
And Mr. Pham, can this circuit be done on multi-sim 7 as well?
Yeah,
Okay, thank you.
you can using multi simulation, multi-7. Okay, so basically that just a repeat again. Okay, so you get a 10 volt minus 10 volt and a Zener 3.3 volt. They want you to draw the output. First thing they're talking about that one. That means you get a 10 volt. Okay. So you know this Zener will be break down. Right? The thing is Zener 5.1. And basically you get 10. So this Zener will be break down. Okay. When they break it down, that means you get right here 5.1 volt. Okay. And 5.1 volt, and this Zener here will be on normal. You adding to 0.7. That's why they given you 5.8 volt. Okay. And now, if you get a minus 10, okay, minus 10. So basically, how come you get minus 4 here?
Okay, let's see. Okay, um,
So
if the first Zener breaks down, right?
now 10 here, minus 10.
Right,
This break down 3.3.
right.
So they cannot break down.
Oh.
You see that? They cannot break down. Only if they break down if they higher than 3.3. Or they higher than 5.1.
Right.
However, they get minus 10. So basically, both diodes, they cannot be break down. Okay? So let's see.
So you're saying treat both diodes like regular diodes?
Yeah. The thing is the voltage is not higher than 0. One 3.3, one 5.1. And basically you get this round here, 0. The other side here, minus 10. Okay? So basically round in here, minus 10 in here, and this diode, okay? Anyway, they will be draw in here. So basically, they on, that means 0.7. Okay. On here will be positive here. And that will be negative here. And negative here. So that will be negative. Let's see, minus 10. Okay. So if this guy 0 here. Oh, okay. I see. This is drawn in here. Okay. So it's a minus 10. And the voltage here will be 0. Then this guy will be break down. Okay, I can tell you.
So the first or the second, yeah, I was gonna ask you that.
For minus 10, right?
Yeah,
Okay. So the D1, let's see, minus 10. And this side here, okay, they can be drawn. Drawn, that means higher than minus 10. So that's why D1 will be breakdown. So that's why you can get VD1. Okay, and when you get a 0 here, and on this side will be negative, okay, that will be telling you D2 will be on. D2 will be on. That means you can get 3.3 here, and that will be around. So that's still confusing to me. Okay.
isn't it? Okay. Oh, no.
Okay.
Well, you would have to add, in order to equal -4 volts, when the D1 voltage went through, and D2 is positive on the lower side, negative on the higher side, wouldn't that make,
That means you can say they will be a negative 3.3.
right,
Okay. And this side will be on negative 0.7.
right.
That's supposed to be. Okay. One will be minus 3.3. And the other one will be minus 0.7.
Mr. Fan, I just didn't get why is -4 volts.
That's what I said. Okay.
I didn't. Can you
One,
repeat, please?
yeah. One Zener will be minus 3.3. And the other Zener will be on normal. So that's why they get minus 0.7. So that's why they're adding up. You can get minus 4.0. Okay, now I'm telling you, if you know how to run the simulation, okay, MC7, then you can measure right here to see what the voltage you get, okay? And you can measure from output to the route. Then you're supposed to get minus 4.04, okay? I not pay attention on
But
that, but I will.
you can't. Sorry, but we can't calculate it, right? Or can we?
Now, we have to try to run simulation to see what the really the voltage here, okay? For negative.
That's
Then
what I was gonna say, Mr. Pham. Maybe, we could try it out on Multisim 7 and measure it, huh?
exactly.
Hey, Mr. Pham, also too, so if I'm doing this on Multisim 7, D1 is supposed to break down at 3.3 and D2 is supposed to break down at 5.1.
Right.
Okay, so I'll just try to do it on Multisim 7.
Okay. That will share this problem later on. Same thing. They just opposite. Okay. I will be trying to run the MSIM7, multi-SIM7, and give them you got more explanations. Okay. Otherwise, we cannot get through that one. Okay. LED. You know, that's a light. Emitting diode. Okay. When they get positive, negative, on, they will be turned it on. And the light. Okay.
Okay, wait, can you repeat that?
Which one?
Just to talk about this again, I'm sorry.
Light emitting diode. Basically, you get positive, you get negative. If the diode on, they get the light on. That's it. Nothing else.
Okay, gotcha.
Okay. If they off, that means the light not turn on. That's a 7 segment. In they get 1, 2, 3, 4, 5, 6, 7. 7 segment, 8 segment, they get diode. Okay. You can see on your watch, you get that. If they want number 9, so you can see which diode will be on. Okay. A on, B on, C on, G on. You get number 9.
E
Okay.
and D will be off.
Yeah. They either on or off, depend on. You got one number 3.
F and E would be off.
Yeah. That's number 3. Okay. Number 8.
All of them be on.
Yeah. That basically they using it in your watch, digital watch. Okay. They going on whatever number. Rectify. It is a sideway. Get positive, negative. When they go to divider,
Can somebody turn their speaker off? You're playing music.
yeah, just a minute.
Thank you.
Can you guys hear anything?
Are you talking, Mr. Pham? We can't hear you.
You hear me now?
Yes.
Okay. Anyway, you get a sideway here, positive and negative. When they go through the divide, they go a rectifier. They come out, you don't see any more negative, right? No negative. Okay? And the signal will be look like only the positive part show. And the negative part, they remove it. Okay? And that's what they call a halfway rectified voltage. Why halfway? This is a full way. And now they just get only positive. Okay? When they go to the divide, they get only positive. No negative. They take it out. That's why they go halfway. Okay, try to see this look like. This is a sideway. Coming in. Okay? When they coming out, same thing here. After rectifier. Then they go through the filter. Okay? What that mean? You go to the filter, that means they try to get the DC voltage. Okay? You can see they can get the DC voltage here. Only DC right here. Okay, a little on the top. You can see they look like. That means on the top of the DC voltage, you can get this signal. That's what they call a ripple. Or that is the noise. Okay, from here to here, DC. On the top of DC, you can see they get a little here. That's what they call ripple or the noise. Okay, by basic definition, what is the noise?
AC riding on DC?
Now, I just try to get the basic definition for the noise. What is the noise?
It's an unwanted signal.
Perfect. Unwanted signal. Okay? That means the signal you don't want it, but they're there. Okay? Then they go to the regulator. That means they try to remove the noise. That's how the picture shows you. Halfway rectifier. Okay? They're telling you this signal they get out here will be halfway rectified. Okay? And then they need the filter here. Inside they get a capacitor. So that's why you get a DC voltage. However, on the top of the DC you get a noise. And they need the regulator to remove that noise. That is the purpose. Okay, now this circuitry we call halfway rectifier. This is the input here. Okay, when the input positive. Okay, so the diode will be on. Correct? However, they on positive here. That's what they coming out. Okay. When you get a negative, the diode will be off, so that's why 0. And they keep repeat again. This circuitry allow only positive, okay, of the signal coming out, but not negative. Okay. However, that's what they said right here. VD0. However, we're working with what they call a second approximation here. That means the diode will be 0.7. So if you drawing the right one, then I'm telling you, when you get a positive diode on that means this side positive, this side negative, and the value will be 0.7 volt. So basically, for drawing with the second approximation, and first thing you have to know, this is minus 0.7. So they will be go this way. Okay. So this is the V pitch right here. V pitch, sorry. V pitch will be from here to 0. So V pitch is not exactly the same here. Okay, the thing is signal will be going down minus 0.7. When you're doing on MSIM7, you can recognize it.
Are you saying V pick or peak?
V pick,
Okay,
that means V pick here.
okay.
However, what I'm saying is, they draw in here, okay? They draw for 0. Right here. VD0. However, we're working with VD 0.7, not 0. So when you get a positive here, so diode on. When they on, substitute by battery 0.7. So at the output, you can get a negative 0.7 volt. Basically, you can see right here. Minus 0.7. So this guy here, this signal here, they have to be going down. They have to be go this way. Okay? So V pick now will be here.
Right. Okay.
So I given you example. Okay? You get 10 volt. Okay? V peak. So what the V peak? After the halfway rectified, they have to be 10 minus
7.7, so 9.3.
yeah. The reason why, the thing is when you measure V peak, you measure from 0, okay, up to the top. However, this signal will be start from minus 0.7. Okay, that's why when you're working on the MCM7, you measure, you can see. Okay, is it that your guy can be working good on the MCM7 or you need help? Do your guy need help on MCM7?
Mr.
There-
Pham, you need to ask them if they loaded it on their computer.
No. My general question, do you have any problem if you try to working simulation MCM7?
I know how to do it.
Yeah, I haven't had too many problems yet.
Is it you don't have any problem or you still not quite understand using MCM7?
I'm not familiar with it.
The reason I asking you, okay, if you guys need help to working on the MCM7 simulation, then I talk to Mr. Tai. I forcing him to helping you. So do you need help or you don't care, you know how to do it?
It sounds like some do and some don't.
It'd be a good idea to go ahead and have him do it, Mr. Pham.
Yeah, I think so.
Okay, I will talk to Mr. Tai tomorrow to get it. He will be try to help you how
Thank
to.
you.
If it's not, your guys still not clear, then I will do it. Okay.
Okay.
The thing is, sometimes the big problem for teaching, something we know, but we don't know how to talk to the students so they can understand. That's a big problem. Okay.
Just as a reminder, typically at the beginning of the class, Mr. Pataya asks if anybody have any questions. So maybe somebody need to remember to ask him tomorrow about the MSIM7.
Exactly.
Yeah.
Just ask him, please help how to run the simulation. Okay? And you still get a problem, then I can help you. Okay? That's good enough for today. Okay?
Okay.
So make sure you can looking into the video and try to get through your quiz number 2. Okay? Using the form in the handout. That form I already know how to see you get A or B or C or D quickly. Okay? I don't have to go through to see number 1 A or B, number 2 C or D. No. I already get the key. I can see right away know what grade to get A or B or C or D. Okay? So have a good weekend, everyone. Okay?
Okay. Are we having a Zoom tomorrow night with
Yeah.
Professor? Okay.
I had
Tomorrow.
one question.
Yeah.
Yeah, so the Excel sheets, do those only accept whole numbers? I kind of have a problem when I'm inputting like decimal numbers with Excel. I'm not really familiar with it, but for like the homework, you know?
I don't-
Oh. You get a problem with the homework or what?
Yeah, it was just, I'm having problems when I submit decimal numbers. Does
Okay.
Excel just take whole numbers only? Is that why?
Okay,
It'll round it up. It'll round it.
Oh,
Yeah.
yeah. It always rounds decimal numbers to 1. So I
Well,
didn't.
if it's like 1.0, you know, it'll be 1, right? And
yeah,
so,
Oh, okay. Huh, that makes sense.
But I think that internally they keep the original number you typed.
Oh, they do. Okay.
Hey, Mr. Pham, so Mr. Ty will be on Zoom tomorrow, correct?
all right,
Okay, thank you.
okay. We'll see you guys.
okay, thank you, Mr. Fan.
Thanks, man.
Yeah,
Have a
Good
no
good one.
night,
problem.
good night.
Good night.
Night.